more at ibm.com/YOU.
Our universe is filled with secrets and mysteries, leaving us with many questions to be answered. We find ourselves searching for those answers as the very fabric of space, science, and society are converging. Here, for the first time, these worlds collide.
Oh, what are you saying?
All you trekkies and TV addicts, don't mean to this, don't mean to bring static. All you Klingons in your grandma's house, grab your backstreet friend, they get loud.
Say, Doc, what's the condition? I'm a man that's on a mission, like a scientist. When I'm applying this,
I'm check it out. What's it all about?
Now, get busy! Welcome to Startalk. I'm Neil deGrasse Tyson, your personal astrophysicist. This week, we're bringing you a special sort of mashup episode all about life on Mars. What would it be like if humans lived there, ate there, and more importantly, played there? We wrangled clips from across the Startalk podcast network. Startalk All-Stars, Playing with Science, Startalk TV, and of course, the original flagship Startalk Radio. The Martian by Andy Weir planted an image of human life on Mars in the public imagination. And I remember the movie. I couldn't get it out of my head. Living there, eating there, surviving there. And so we have to ask, is that image scientifically accurate? Let's find out in our first clip featuring Bill Nye, Andy Weir, Eugene Merman, Maeve Higgins, and NASA Planetary Science Director Jim Green.
is there life on Mars?
So I've always been a science dork, and I've always loved this stuff, and I came up with this idea for an astronaut stranded on Mars, but I wanted everything to be physically accurate, just because I always get taken out of a story when I see some blatant physical inaccuracy.
The book is fairly accurate too, right, or very accurate?
Oh, the book's delightful in many ways, but you know, it is...
Sorry, I meant to say, is the book delightful scientifically?
Let me think about that. So, you know, it's science fiction. There are things in the book that, you know, we don't find on Mars. Not yet, anyway. Might happen
Exempli gratia, for example.
Oh. Well, Matt Damon's not on there. Yeah.
But there is a guy from Boston.
Probably buried. Is that what you meant? Buried somewhere on Mars? So,
yeah, from the Big Dig.
Turns out that's where Jimmy Hoffa is. The dust storm. Okay, you know, Mars has famous dust storms. They go, you know, global sometimes.
You can see them with telescopes from Earth, right?
Yeah, absolutely. And they look gnarly from space sometimes. But in reality, the pressure is so low.
How low is it?
It's very low. It's about 1/200
atmosphere.
Yeah,
1/200
of the atmosphere, roughly, of what we have. You know, and so although the winds can be pretty hefty, it can be 120 miles an hour, but that's not enough to straighten an American flag, let alone blow away a radio dish.
Because there's so few molecules going that fast.
Right, that's right.
So you did you have trouble watching the movie with all its lies then?
No, absolutely not.
Were you like, another lie, another lie? Stop lying to me, Ridley.
Oh, you're going to put it on Ridley? All right. Yeah, I could.
Yeah.
Freaking Ridley. Now, what you got to do...
Your book's accurate, delightfully so.
Delightfully so. But you got to check the science at the door and go on in and enjoy it. It's enjoyable. It's great.
You
know, I do that kind of stuff all day long. Why do I want to sit in the movie theater and think about some more of it?
Andy, as Nerdman, you had to work out some serious scientific problems.
Yeah, I did. Yes, absolutely. The dust storm or the sandstorm is inaccurate, and I knew that at the time. I just didn't care. I wanted a good reason to strand him there, and at the time I wrote it, most people didn't know that. Like, most people thought that a sandstorm on Mars. But then, because The Martian got so popular and became a very popular movie, and then got a bunch of scientists talking about it, now everybody knows a dust storm on Mars can't do that. So I shot myself in the foot.
It was, you blew the thing over and you couldn't see.
Right.
Oh, man.
Yeah, what are those chunks, by the way, that were coming out? You know?
Yeah, I don't know.
Space debris.
One of my favorite things is how JPL almost ruined everything. When I wrote the book, it was done. It was already in final editing. I can't make any more changes, or other than like copy editing, and like at that point, like they were deciding, they had it down to the final 4 candidates of where they're going to land Curiosity. They eventually landed it, near Mount Sharp and Gale Crater. But one of the Mount Sharp, Gale Crater
on Mars.
Yeah, I'm on
the
Mars.
big one,
right on Mars, which is thousands and thousands of kilometers away from all the things that happen in the Martian. Not a problem. One of the final 4 candidates on where they were thinking about landing it was Marth Vallis, which Mark drives through. Like, I specifically call it out in the book. He drives through this ravine, Marth Vallis. He would have had to have gone around the rover to keep going. And I'm like, oh, you guys are killing me with your stupid real stuff. And then my favorite little
It's like they didn't even take that into account.
It's like they, nobody asked me.
Yeah, I don't know what I was thinking. Sorry about that.
Yeah, I know.
So, Jim, what about the final decision?
No, actually I didn't. But we were down to the last 4, and I loved any one of those. So my boss did, and that was Ed Weiler at the time. And
So, everybody, this is the real guy. That's all I'm saying.
This is so just so we're clear, the character in the book, Venkat Kapoor, who is in the movie Vincent Kapoor, he holds that position in the real NASA. So if you're curious, that's who he is. So,
your tax dollars at work.
That's right. And they work, too.
But my favorite little, stories of space research screwing with me is the University of Arizona that runs the HiRISE instrument.
High resolution camera. Orbiting Mars.
Apparently we have 4 of their alumni here today. But
4 people who are great at clapping.
They
just
the
got
book,
the joke Bill made 10 minutes ago.
In the book, well, they're U of A, but
somebody got it.
Yeah, but in the book, I give the exact latitude and longitude of the HAB, and so
the HAB is the
habitat, the base where most of the Martian takes place, where Mark Watney is stranded, where they are, their landing site, habitat. And so I describe the terrain as being kind of flat and sandy. There's not much going on in Acidalia Planitia. It's a large empty desert and stuff like that. And the guys who run HiRISE are like, let's check. And so they did these super high-res photos of the HAB's location on the real Mars. And they're like, well, that's nothing like he described it.
Yeah, but Ridley got it right. Because there are some beautiful craters right around where that HAB would be, and the scenery looks great.
Yeah,
those people must hate Star Wars.
Almost.
So they don't have good resolution on galaxies far, far away.
We don't have a camera for that yet.
Yeah, we're working on it.
Okay, thank you.
So the guy's on Mars. He's got a lot of food. Because there were supposed to be 6 people, but he's only 1?
Yeah, and they left, in the book, they left after 6 days of a planned 31-day mission, and they had redundant food supplies. So he had enough food to last about 400 sols. A sol is a day on Mars, for the 4 of you who don't know that. Well, 3 of you and 1 of her, I guess.
Wait, I know it is that, but why is that? Why is it called a sol?
Sol is Latin for sun. It just means, because day is an ambiguous term. Day to scientists means the time it takes Earth to rotate once on its axis, just Earth. So Mars rotating on its axis, that's one Martian sol.
I remember during the disco era.
A different soul.
That's right.
Different soul. The soul train.
Tell us what Studio 54 was like, Bill.
I don't remember, man.
Yeah, he was there.
Bill Nye, science high guy.
Bill.
Stereotypes. You don't always do that well with the ladies. The stereotypical male in here. I know it's shocking.
In our next clip, I chat with Chuck Nice, astronaut Mike Massimino, and author Mary Roach about handling waste on Mars and an unusual space snack. We came off the segment talking about food, comfort food. What's your favorite? You love the lasagna, but lasagna is not comfort food.
For an Italian kid, it is.
Okay.
Macaroni and cheese.
You got mac and cheese.
Shrimp cocktail is a favorite. I don't know if that's comfort food. I really don't know what comfort food is. To me, it's food.
Shrimp cocktail.
About anything.
Comfort food for the bushes. Yes.
All right. So, we have hamburgers. Comfort food for the
Depends on how wealthy you are.
You want some good food. You know, the idea of wanting to look out the window and not worrying about food, that's when you're applying to get on the mission. Yeah, I don't need food. I'll eat granola bars. But after you get assigned, you're going to want to eat. So the quality of the food is going to have to be pretty good, I think.
And Chuck, you said the Jamaicans why would they make good astronauts?
Because, think about it, man. You know, everything that you need to deal with, your stress and food issues are taken care of with one little Rasta puff.
That's how that works.
If your fellow astronaut is on your, hey man, go ahead and smoke these.
I'm guessing there's no smoking in space.
Yeah, there's not just that, but there's a few issues there. I don't know if we want to go there. But that might not be an easy. It might sound like an easy solution, but
not really.
It might not work as well as you think. Space flight is tough in that way.
We just put it in a pouch. You add water and put it in the oven. No smoking necessary.
No comment.
That's right. We put them in brownies.
So what's fun is if you create a Mars settlement, there's food you might bring, but maybe you don't want to bring food. You bring seeds, you bring sort of baby animals, and then you sort of raise livestock on Mars. That way the astronauts they didn't have a real burger. You know, you can have like Kobe beef on Mars. Maybe. I interviewed Mary Roach, author of Packing for Mars. Let's see what she says about Mars settlements. I think we know enough about space. We don't have to send animals to Mars first. What a waste of money that would be.
No, nobody's going to do that. Unless someone decides. There was this wonderful paper from a 1964 conference on space nutrition and related waste issues. Okay,
That's the title of the conference?
That's the title of the conference. If you were to bring livestock to Mars, like if you're going to bring animals and have ranching going on, what would be the best species to bring in terms of how much it costs to launch them versus how many calories you get? And he did an analysis of cows.
I would include taste in there, too. Somehow quantify taste.
I don't think he did because the winner was mice. Mouse stew.
Ew.
Yeah.
So mice are more efficient.
That's what he determined, that you should
launch mice.
That.
You know why I can't believe it? Because
there's not much meat on a mouse.
That's what I'm saying. I once ate a squirrel when I was in Texas. There's barely any meat on a squirrel. You know there's nothing on a mouse.
You got to take it up with Max Kleiber.
Could it be that mice, they have a very short gestation period, so they can multiply their generations very quickly?
That could have been it. But just think of the steer, talk about waste issues.
No, then it's fertilizer for the plants that you're going to grow.
Or it becomes radiation shielding because you want your hydrocarbons.
So manure being radiation shield.
NASA has a device down at Ames that can take...
Ames Research Center in California.
Yes. It's kind of like an easy bake oven where you would take waste material and kind of plasticize it in a tile, and you could line the capsule with that. On your way home, you'd use that for radiation.
You take animal poop, put it in an easy bake oven.
Or human.
Yeah, well, humans are animals. And so it hardens.
It becomes a tile, like the ceiling tiles.
And so you line your craft with this.
It's a good radiation.
It doesn't smell? I mean, you have to coat it.
It's sealed in plastic.
But it is interesting because if you go to another place, you're thinking you're going to take food that you would be comfortable with eating and might want to sustain. So it would be like an ark, right? You wouldn't just take a cow, you could take a cow and a bull. No, more likely a cow and bull sperm, right?
Right.
Okay, because bull sperm weighs less than a cow. Sorry, I just did the math on that one. That's just how that works. So Mike, if you eat mouse stew, if that's all you could eat, would you go to Mars?
That's what I would say if that was my interview question, if I could go, yes. And then after I got assigned to the mission, I wouldn't be eating any mouse.
Right. Boy, mice cannot catch a break.
I'm telling you.
God.
No, we're not eating mouse.
I'm telling you. It's just interesting using animal waste to line the aircraft because it's still this radiation problem unsolved.
Yeah, I think it shows the way you have to think out of the box for this type of trip. And any crazy idea might seem a little bit nutty. You need to think about if it's going to help you. You need to think creatively.
That's more like thinking out of the butt, not out of the box.
Yeah,
I'm sorry.
Yeah,
Calm, I can't hold it together.
Right.
Crappy shields are crapping out.
Quick, poop, we're in danger. We need more poop. Yeah, I don't know. I'm trying to give some credence to it.
It's odd because it'll all change. It's just what we think of as what will sustain us.
Right.
You have to be, we say that about other foods in other countries. Oh, it's a delicacy in whatever, and it's,
Yeah, don't fall for that, though.
Right.
Would you like to listen to Neil deGrasse Tyson explain black holes or gravitational waves? Want to hear Bill Nye talk about climate change or GMOs? Did you know that you can search the entire Startalk podcast network by subject or host or guest? It's easy. Just head on over to www.startalkradio.net and search for pretty much any scientific subject in the universe, and it's likely we've got something to say about it. Or as I like to say, if it's out there, we've got it in here. Did you like what I did there? Oh my God, I'm rhyming. I can't stop myself. It's just my timing. Oh, I am so sorry.
This is Startalk.
Hi, I'm Neil deGrasse Tyson, your personal astrophysicist. This week is a special mashup edition. You'll hear a mishmash of some of our favorite moments around a specific topic using a range of expert guests and co-hosts. And we've selected segments from anything and everything under the umbrella of the Startalk Radio Podcast Network. And that includes Startalk Radio, Startalk All-Stars, and of course, Playing with Science.
Hello, this is Mike Massimino at Astro Mike, talking to you from Startalk All-Stars. I guess I'm actually an all-star.
Yeah.
I haven't been an all-star since I was 13 years old in Little League. That was 40 years ago, but I'm an all-star again, and your host tonight. And I have with me my friend. Wait, can I call you my friend?
Yes, please.
Maeve Higgins is my new friend. No, we're friends, and she is a tremendous, great space enthusiast, but more important, a comedian, so she's going to keep us laughing. Thank you for being here.
No, thank you for having me.
You bet. And I'm very excited because a good friend of mine who I work with at the Johnson Space Center, John Charles, really smart guy. Mm-hmm. He's a scientist. He's actually a chief scientist.
So there's scientists and then there's chief scientists.
There's scientists and then there's chiefs.
Mm-hmm. And there's like baby scientists.
And you got to grow up to be a chief. You don't start out as a chief. They check you out and they're like, okay, we're going to make this guy a chief. And John is a really smart, well-spoken genius, although he'll never say this, but he certainly is. He's the head of our NASA Human Research Program, chief scientist for the NASA Human Research Program, trying to get people to the moon, to Mars, off the planet, far away, and taking care of them.
Whoa, thanks for making time to talk to us, two bozos, John.
John Charles.
Tell you what, Mike, with an intro like that, I'm glad I made it.
I'm really glad that you're here. And we're going to talk about what it takes to get people to Mars. People on Mars. That's right. People like you and me, maybe not you and me, but people like us, real people. But John, what did you think about the movie to Mars? I'm sure you get questions all the time about that. What was your opinion?
Well, I enjoyed it. I thought it was probably the best space movie since 2001, and we can argue about whether it was better than 2001. My wife says she prefers not to go to space movies with me because all I do is huff and puff and roll my eyes audibly usually during the entire movie, but she said I behaved myself well this time. You know, Andy has said that the opening event, you know, the wind that blows everything around and causes the problem, couldn't happen on Mars. The atmosphere is too thin, and the dust is not sandy, grainy, granular like that. It's more the texture of smoke particles. And he said, I asked him that question during a Q&A one time, and he said, yes, I know, but I needed to start the movie somehow, and that's how I chose to do it, and it turned out okay.
Did you just show up at a Q&A like a regular citizen? Like, he didn't know that you had all this surprise?
No. He actually came to Johnson Space Center and did a series of book talks and Q&As for all of us nerds, so he was very well prepared for the audience, and we all loved him.
Yeah, John was a plant.
Yeah.
You go in there and say, hey, what was wrong? But that was, and the EVA scene, the spacewalking scene at the end, as soon as you mentioned that, my son and I saw it together, and he said the same thing. He goes, Dad, what kind of spacewalk are they doing? Even my son, my son was picked up on it.
Yeah.
Yes, it was very unterspersonal the way they were untethered at the end.
Well, you were like, but wasn't it cool when he pulled the antenna out of it?
Right, I said, yeah, don't worry about that. Matt Damon was a cool astronaut. This one's approved.
It's good. It must be great, like, PR, right? Like, that's like when you see a great movie about space, like, it makes you think highly of NASA for some reason.
I think so. What do you think, John? I think that was good for us, wasn't it?
I agree. We certainly used it for a lot of publicity. We tried to link a lot of the one-year mission space station work to it and things like that. So yeah, I thought it was great.
Johnny, but there's also this serious part to what the movie portrayed, which was how do you keep a crew alive? Now, he was in a survival situation, but still, there must be a lot of parallels with the work you're doing to what you saw in that movie, right? Food and water and life support and so on, yeah?
Exactly. Well, I mean, the food was one of the, actually, a potato was like another supporting actor in the whole movie. And
that's
your
like
buddy,
in the whole history of Ireland.
But Mike, your pal, Don
Potatoes
Pettit.
are huge for us.
Have you heard what Don Pettit said about potatoes in space, though, Mike?
No, Don Pettit is one of my best friends.
Oh.
And a very entertaining guy and a genius. Very rare for an astronaut, let me add. Like, what did he say this time?
Don Pettit said he's never seen a potato on the space station or on the shuttle that was not sliced and had its eyes cut out. So there's no way a potato in space would have been able to grow and produce more potatoes.
But Don did actually grow stuff in space, and they are growing stuff on the space. But Don grew his own. He grew a sunflower and he grew a squash. Yeah, it was kind of on his own. Wow. But he did his own little experiment. But they have grown also lettuce on the space station
on purpose,
as well.
Yeah.
On purpose,
we have special seeds we fly up to do that kind of research to eventually lead to growing fresh
I knew it was
food
on purpose. I didn't think it was like an accidental.
No, what I'm saying, some guys some astronauts might do things because they're interested in their own experiments. But this was the lettuce was a real, growing the lettuce was a real project that they had, and it was successful. So you can't to grow your own food in space.
Yeah.
And then they eat the results.
And then you eat the results, and they're good, hopefully. Go ahead, man.
I was just going to ask about water.
Yeah.
That's what I was going to ask.
One.
Like, how on earth could you provide water for people on Mars? Could you find it there? What's going to happen there?
Well, you have to bring it with you, probably, at least the starter kit for water. And then the point is, with any luck, you can generate water out of in situ resources. And of course, what you have on Mars in situ is carbon dioxide. It's a very thin atmosphere, but it's almost completely carbon dioxide.
Yeah.
And if you bring along the right kind of machinery that knows how to crack carbon dioxide, and if you brought along a tank of hydrogen with you, you can get oxygen and water out of the reaction of carbon dioxide and hydrogen. Using chemistry that is far beyond my capability to explain, but it's a possibility. So if you're there for the long term, you got to plan ahead and either bring stuff with you or make it from local resources.
You're also going to recycle it, aren't you, John? I mean, that's what we're doing on this. As my friend Don Pettit, who we referred to earlier, describes, today's coffee is tomorrow's coffee. Right? You drink something, you pee it, and then you drink it again.
Yeah.
That
explains Starbucks.
There's a couple steps in between there, by the way. But that's going to be the plan, too, I would assume. Right, John?
Exactly right. Exactly.
And what would it look like to live? Like, where would you live in Mars? Like, what would it look like? What would your, I was going to say tent. That's because I've seen the movie. But where would you sleep and live?
Habitat.
Your habitat. Yeah, that's the word.
Yeah, the habitat would probably look very much like you saw in the movie, and that was actually based on a habitat that we're doing studies in on the ground, which was, of course, primarily designed for studies back in the deserts. So it's probably going to look something like a repurposed spaceship. It might be inflatable. It might be rigidized. Certainly, we're only not just now doing research on the right way to do that. So there's no final answer yet.
It sounds like the Burning Man Festival. I don't know if you ever sent anybody on a research trip to Burning Man, where you have to like bring your own water and tents, and everyone is really spaced out.
Yeah.
Woodstock.
This is Startalk.
Welcome to the Space Olympics, the year 3022. Take part in a grand tradition. Your name echoes in the halls of the universe.
Today we enter Twitterdom through the vast multiverses of Neil deGrasse Tyson's mind and light up the cerebral spheres that engage with the complex and ever-evolving world of sport.
Yeah, so did you change your meds?
Slightly.
Hey, Neil deGrasse Tyson has many opinions and many things which he chooses to share on a regular basis, but he has a heartfelt connection to sports that's constantly filtered through his scientific lens on Twitter.
So when you play with science, there can be no better playdate than the man himself.
Yes.
And to take us to sports that are out of this world.
Out of this world sports.
Yes, indeed. Out of this world sports, we have Neil deGrasse Tyson.
Yes, thanks for joining us right now. It's the one,
the only,
the inimitable Neil deGrasse Tyson! You like that?
Scared?
That's
Where'd
right.
you get the gong?
Yeah.
Oh my God. Normally that's how you get someone off the stage, right? I saw the gong show.
All righty. No, don't take it personally.
No, that is a royal entrance right there. That's what the gong is for.
Now, normally I'm sitting there.
That's right, sir.
Now you just took your own damn show. Now I'm a guest on your damn show.
Weirding you out? Are you comfortable? Are you okay?
I'll get used to it. That's all right.
It doesn't happen without you, no matter what, though. What's up?
Neil's going to start asking us questions. He won't be able to help himself.
Yeah, no,
I'll
happily be your guest on this show.
Yeah, that's
Thank you.
please don't ask us any questions.
It means I feel loved. I feel loved. Yeah.
That's very cool. Thanks for being here, man. We appreciate it. And of course, you are a prolific tweeter.
So this is from the 2012 Olympics.
All right.
I said, how about a Mars Olympics? Yes, all athletes would suffocate. Ignoring that complication, way cooler than an Earth Olympics. That's all.
Way cooler than an Earth Olympics.
I'm setting you up for tweets that follow.
Yes, I was going to say, because when you say way cooler, then you actually give us some examples of why an Olympics on Mars, or pretty much any sporting event on Mars, might be cool.
It's also a couple hundred degrees below zero on Mars, so way cooler has double meaning there.
I think we picked that one up.
Picked that up, okay.
All right, so let's look at one of the Mars tweets, and this is cycling on Mars.
Okay, all right.
So go ahead.
All right, so this is again during the summer 2012 Olympics. If there was cycling on Mars, try Olympic Mons, a volcanic mountain 5 times taller than Mont Blanc in the Alps.
Wow.
So you think you got tall mountains here? No, the tallest mountains and the deepest valleys are not on Earth. In the solar system, they're on Mars, they're on the Moon. So we ain't got we're not winning those contests.
Because you'll know this, the atmosphere on Mars is how much less than the Earth's atmosphere?
It's about 1/100th. Yeah.
So if we had
pressure, atmospheric pressure. So in other words, for every breath you take on Mars, there's 1/100th the amount of air in that breath, and it would be on
as an
Earth.
athlete, altitude becomes your enemy. In terms of the oxygenation.
If you're performing in altitude, but the ideal way to do this is you train in altitude and then compete at sea level.
Right.
What we need to do is go to Mars.
That's why Sherpas don't have any problem getting up the mountain while all the tourists are like,
that's right.
All the baggage.
I need more oxygen.
So here's what you do. Even better.
Train on Mars.
I'm going to make a suggestion that's never been made before. You ready?
Yeah, here we are.
You drain the Pacific Ocean.
Okay.
Oh.
And then hold the Olympics at the bottom of the Marianas Trench. But you train at high altitude, but now you compete at the bottom of it, which is 6 miles down. Now every breath of air has way more oxygen than at sea level. And so now you have heroic feats. Before, you don't even have to dope your blood. The air itself will put the oxygen and force it right into your lungs.
Sure, the IOC are going to stump up for that draining of the
I was going to say, I just like the fact that you're thinking like a supervillain.
See, I'd have gone the other way and said, let's all go train on Mars, on the mountain.
On the Olympic Mons.
And come back to Earth and compete.
Problem is, it's only 40% the gravity of Earth. So the weight that you are carrying is not as much going up the hill.
Gotcha.
Yeah.
Right. So there is some trade-off.
There's some trade-offs.
There's some trade-off there.
Some leaded suits.
Right.
Oh, yeah. You just led yourself down. Another thing, once you've drained the Pacific Ocean, that has nothing to do with sports, just while we're on the topic. If you drain the Pacific Ocean, that is the great toilet bowl of dead satellites.
Oh, really?
Yes.
Oh, yeah, because they always splash down in the Pacific.
Oh, they crash down. If it's a dead satellite, they're not splashing.
They're not splashing down. They're crashing down.
Yeah. So the reason why is the Pacific Ocean is almost a third of all possible longitudes on Earth.
Right.
So if you deorbit and you do it, you have a lot of latitude, no pun intended, to where you begin the deorbit so that it's going to plunk down in the Pacific no matter what. And people don't live there, so not over the great bulk of the expanse.
Right.
So it's a safe place to drop your stuff out of orbit. The day we deorbit Hubble, it's going straight into the Pacific.
Going into the
Pacific
Ocean.
Hubble, and it's the size of a Greyhound bus, by the way, if you know.
Nice.
Hubble telescope.
All right.
Yeah.
So this is one of my favorite.
Okay.
We actually talked about this in a different form on Startalk, and it's swimming on Mars.
Okay, so here it is again. The same week. If there was swimming on Mars, the low temperature and low air pressure would force the pool to simultaneously freeze and boil.
Sweet.
How many hours does Phelps have to train to cope with freezing and boiling simultaneously? Because he's up to about 50,000.
There it is gurgling, and there are chunks of ice in there as well.
So at the same time, so can you explain that?
I don't know how you get to that situation.
How do you get to that situation?
Okay, so in chemistry, in physics as well, it's called the triple point.
Okay.
So, which is a cool name. The triple point of a substance is the point where it is happy being solid, liquid, and gas all at the same time.
All at the same time.
Okay? So now, that sounds freaky because it's outside of our common life experience.
Right.
But it's less so than you might think.
Go on, then.
Okay? So, take a look at dry ice, okay, CO2.
Right. Okay.
That's in a double point of its state. So it is simultaneously a solid and a vapor.
Right.
It's happening all at once.
Yes.
Okay, you open the thing up, the vapor comes out and it's solid.
Right.
So that's a double point that it's occupying. That's not as interesting as the triple point.
But it does make for awesome concerts.
So here... so here's how I think they use other smoke for that. Rather, I think they got that done.
They used to use dry ice back in the day, but you're right. They use smoke machines now.
But 80 years ago, when Twisted Sister performed in '03, So here's how it works. You know that when you go to high altitude, it affects cooking times because water boils at a lower temperature.
Right.
You know this. Instead of 212, if we're all using imperial units, it could boil at 200 degrees or 180 degrees. Okay. So you have to increase the cooking time because the food is not at the high temperature for as long, and you can't get boiling water hotter than the temperature that it's boiling at.
Right.
All right. One of the earliest experiments I did with my kids, so they understood this. I would start boiling a pot of water. I give them a thermometer. Say, measure the temperature. And it's like 100 degrees. 3 minutes later, measure it again, 110 degrees, 120. They keep doing this. And I say, there's heat going into it. They say, yep, we see the flame. My kids are like 6 and 7 and 8. So then it's like 200 degrees. They check it again. 205, 210, 212. Okay, 10 minutes later, measure it again. Still 212. Where's the energy going?
Right.
Oh my gosh, it stops going because water, and at that air pressure,
right,
it's got to become
gas.
Right. So now you lower the air pressure, the boiling point drops.
Right.
And the more you lower the air pressure, the lower the boiling point drops.
Right.
And eventually, the boiling point meets the freezing point of water.
Oh.
And now you have frozen water, liquid water, and boiling water all in the same pot.
point. That's great. Awesome. Hey, before we jump back into it, I just realized something. So, when you were talking about volleyball on Mars, burning the skin because no UV protection.
Yeah. By the way, Mars is farther away from the sun than is Earth.
Right.
So was it 1.4? Carry the 2.
Always don't you get it wrong.
You'll get, so Mars has about 1/2 the solar intensity than does Mars. So in any given amount of time, all other things being equal, it would take you twice as long to get sunburned. But Mars does not have a UV layer.
Right.
I mean, an ozone layer. Right, because there's no free oxygen on Mars.
Right.
So on Earth, free oxygen is the oxygen we breathe. That's O2.
Right.
Oxygen binds with itself. The ozone layer high up in the atmosphere is 3 oxygen atoms. And the reason why that blocks UV, do you ever wonder why? How?
I did not.
Okay. So this molecule is sitting there fat and happy in the upper atmosphere.
Okay.
And one of its bonds that binds these molecules together is the same energetics as that of an ultraviolet particle of light, an ultraviolet photon.
That's it.
Ultraviolet photon comes in, it is just what it needs to bust it open.
Right.
So the energy of the light is gone, and it got converted to breaking apart this molecule.
Right.
So basically ate the UV molecule.
So that
the UV photon.
Right. That actual molecular bond becomes a natural block. Like it's literally like a blocking tackle.
Literal block. And if there's a very close explosion to us in our solar system, supernova, you can calculate. Because it takes a while to regenerate the ozone, right? Because it's a stable layer. You win some, you lose some. Right. Get remanufactured.
Thank you, Al Gore.
Okay, so watch what happens. So if you have a nearby supernova, which has a lot of UV, the waves of UV light take out your ozone, and then the next wave goes through without conflict.
Wow. So the first wave...
It's just like an army. Right. It's exactly like army waves of armies. And so the ozone can only protect you so much before it has to rebuild itself if you have a major flux of UV coming in.
What's the timeline on a rebuild?
What to calculate that? I don't. Okay. It has many sources. Lightning can actually regenerate. You can put energy back in to recreate this... because different chemical reactions are exothermic and endothermic, and it's the balance of all of these that creates the chemical cocktail that is our atmosphere.
Nice.
So so other mechanisms can regenerate it, and whatever those mechanisms are, you can construct actual things in the universe that will override them, such as supernova explosions. Yeah.
Any other planets or moons in our solar system with a similar ozone layer?
No, because we get our oxygen from life.
Right.
I used to think in Star Trek, oh, Captain, this is an oxygen-nitrogen atmosphere. We can go down and breathe it. I said, all we have to do is look around the universe for a planet that happens to have the chemical mixture that Earth has.
Right.
And then I realized, no, that's not how it works. It's not that every planet's got its own mixture. It's that Earth has oxygen because we have life.
Right.
Because the photosynthesis, all the green plants make that oxygen, and that's like rocket fuel for animals. Then animals can now rise up, metabolize oxygen, and we have this harmony of plants and animals.
Sweet. There's a starman waiting in the sky. He'd like to come and meet us, but he thinks he'd blow our minds. There's a starman waiting in the sky.
Hey, I want to talk to you about StarTalk All Access for a moment. When we started our premium subscription service, we thought fans would be more interested in getting to watch video versions of our podcast or enjoy ad-free versions of our show. But it turns out our fans' favorite part of All Access is the new and exclusive original content that we post every week. We're talking about classic videos like me and Neil deGrasse Tyson chilling in his office touching his meteorite. Oh, you heard me. Or the time Neil and Adam Savage hung out in the green room before our show at Comic-Con and talked about Star Wars, Blade Runner, A Space Odyssey, and other really geeky science stuff. StarTalk All Access is your universal hub for all the great StarTalk content you crave, all in one place, including full video of most current episodes, commercial-free audio and video podcasts, live-streamed events, insider-only looks behind the scenes, the ability to watch on Amazon Fire, Apple TV, and Roku, and, of course, new exclusive original content added every week. To get started, visit StarTalkAllAccess.com to subscribe for $4.99 a month with a 2-day free trial. That's StarTalkAllAccess.com. And as a friend of mine says, keep looking up.
Bringing space and science down to Earth. You're listening to Startalk.
Welcome back to Startalk. This week is a special mashup edition. You're going to hear clips from some of our favorite discussions across the Startalk network. So let's get right back to it.
So this is somebody who wants to know about the atmosphere and the gravity on Mars. But I love the way that Stephen Matlow phrases this question, somewhat inventive.
And this came over which path?
This came over Facebook. And he says, okay, Neil, when the New York Yankees play a road series against the Mars Cosmos, how big will the outfield have to be to prevent everybody from hitting home runs? Also, will the pitcher throw faster in the atmosphere or slower? And will he or she, this guy's very liberal.
Nice.
He's got a female pitcher in the Major League Interstellar
Interplanetary.
Baseball, interplanetary, not interstellar, interplanetary baseball league. Will he or she be able to throw a curve ball? And he, take it back, Stephen is coming from Livingston, Montana.
Livingston, Montana.
Yes.
Whoa.
Yes, flat country.
Now, here's something.
Guy never seen a mountain in his life.
That's why it's called Montana. Yes, okay. So, I was in Montana recently. I gave a talk in Bozeman, Montana.
Oh, really?
Yep. 6,000 people showed up for it.
Nice.
I didn't know that many people lived in Montana.
I think you had the entire state there, to be honest. And by the way, I was joking about mountains, because there are mountains in Montana.
That's why it's called Montana.
Exactly. Mon.
It's big sky.
Big sky.
It's big sky,
Big
but
sky.
yeah, they're mountains in Montana.
But go ahead. So here's this question.
I got the question. I remember. You read it. I got it. I have a good memory.
Excuse me.
I have an awesome memory from 3 minutes ago.
I know.
So, a couple of things don't change and other things do.
Okay.
The pitcher does not throw faster because that's just their musculoskeletal capacity to do so.
All right.
The ball will not slow down as much between release of the fingertip and crossing home plate because the air is thinner and there is air resistance to the ball.
Right.
That slows it down. I don't know, maybe 10 miles an hour or 5, whatever it is, 5 miles an hour. It's not traveling for very long, but it will slow down a little bit. It does that in the majors. It will do that on Mars, but it will slow down by a little bit less.
A little bit less.
But that's not the major thing going on here. The Martian atmosphere is very thin.
Gotcha.
It's like 1% of our thickness. And it's the air, the movement of the ball through the air that enables it to curve.
Right.
So curveballs would be very hard on Mars.
Because you don't have the air or the thickness of the air.
The thickness of the air.
For those, what do they call stitches?
Stitches, yes.
Right? Is that what they call?
Is that what they call the stitches on the ball?
The stitches?
They call them the stitches.
The stitches? Do they call the stitches on the ball the stitches?
Yes.
But, that's what's causing that rotation.
Well, it assists it. Even if it didn't have stitches, you could still move it. Right.
Oh, really? Okay.
Oh, yeah.
But
the stitches help it, definitely.
But without the thickness of the air, you can't get that movement?
You don't get as much movement.
Okay.
Oh, yeah. You don't get as much movement. Now, it is windy on Mars, so you could throw an awesome knuckleball.
Nice.
Because knuckleballs don't rotate, and so they're not stable moving through the air.
Right.
Rotating things are stabilized. That's why a rotating football is stable.
Spinning.
Okay, so a knuckleball does not spin. Therefore, it is susceptible to any possible puff of air that comes across its path.
So you could use a windy day knuckleball to create the effect of a curveball.
Well, yeah, but it'll curve in a way that you can't predict, and that's why catchers are always dropping knuckleballs because they don't know where the hell the ball's jiggling and wiggling, and it comes in, and so the number of passed knuckleballs by a catcher is huge relative to other pitchers.
Because it's a surprise ball.
But it's a surprise ball for everybody,
right?
Even the pitcher. A curveball, the catcher calls for the curveball, so they know.
So he knows what he's doing.
Yeah, they know where it's coming. So
this is what I love. This is what I love about you, man. I mean this. I swear to God. See, this is what's great. We're talking about baseball on Mars, but yet you know all this crap about baseball.
Well,
how does this happen?
No, you know what it is? It's not like, I mean, but I like, I'm a red-blooded American. I like me some baseball and hot dogs, okay? And apple pie.
All right.
So just start there.
Okay.
So now the rest of it is just because I go to a baseball game and I'm curious about it. Like, I just ask questions of the game and of myself relevant to the game.
Gotcha.
So, for example, I say to myself, suppose you're hit by a pitch on ball 4.
Right.
You ought to be able to go to second base. Right?
Exactly.
I'm just saying.
Yeah, true.
I'm just saying.
No, that makes sense when you think about it.
These are the kind of questions I asked about the game.
That's very funny.
Okay.
Yeah.
So now
we got to get that rule in baseball. That's awesome.
Okay. So now, how big a stadium would you have to make? Martian gravity is about 40% of Earth's gravity.
Okay.
So if you weigh 100 pounds on Earth, you weigh 40 pounds on, or 38 pounds on Mars.
Gotcha.
So 200 pounds, you weigh 80 pounds, which is great because the muscles that you have for carrying a 200-pound body will now be operating in an 80-pound body. So you'll be able to jump higher. Okay.
Yeah.
You'd be able, so maybe you'd make the infield a little bigger because you'd be leaping. You'd have to sort of adjust that. There'd be some trial and error on this to get the ideal field size. Now, when you hit a home run, the ball is doing two things. It's going forward and it's going upwards.
Right.
Okay. And then it finishes going upwards and then it starts coming downwards while it's still going forwards.
Right.
Each of those have a different effect. Okay. How fast you can hit the thing going forward has nothing to do with being on Mars.
Okay.
That's just how fast did you swing the bat.
That's your swing strength.
It's your swing strength. Now, the ball going up, okay, the same force will have the ball go higher than on Earth, which means it will travel farther simply because it'll go higher.
Right.
All right. And so you got to do the math. I haven't done the math on that. So
I
don't have, if I were to guess, make it 40% bigger. I mean, just as a first cut.
A general rule.
Just a first cut. And probably if I do the math, there are some adjustments in there.
Right.
So a 400 dead center field, 40% greater than that would be 160 more feet. And is that right? Yeah, 160 more feet. So it'll be 560 feet dead center.
Right.
Just to recreate the same likelihood
of a home run.
Now, that means outfield is huge.
Right.
Which means you got to have some fast outfielders.
That is true.
You might have to add 2 more outfielders to it.
Yeah, because
it fans out from home plate. Right. So if it's 560 dead center, you're gonna be missing a lot of balls. Unless you be like Little League, you add a 4th outfielder.
Bringing space and science down to Earth. You're listening to Startalk.
Lifelong dream. All I want to be is an astronaut.
We're live from Town Hall, Midtown, New York. Welcome back to Startalk Live. I'm your host, Neil deGrasse Tyson. I'm an astrophysicist with the American Museum of Natural History right here in New York, where I also serve as the director of the Hayden Planetarium. And I've got with me Eugene Merman, comedian extraordinaire. Eugene, thank you.
And with me is John Oliver, England's gift to America.
And John, you got this regular gig on The Daily Show.
I do.
Very cool.
That's right. Normally it would be cooler, but I am sitting with an astronaut. So it only compounds the failure that the 6-year-old version of myself.
Annie Shaken, you become a journalist in your later years, an author, writing about space, and a geologist by background, a planetary geologist. Welcome to Startalk Live.
Thank you.
The one, the only, the truly inimitable Buzz Aldrin, ladies and gentlemen.
Do you think that people would come? We've seen the pictures of what Mars looks like, and I love Mars as a planet as much as anybody. But to look at it every day, with the brown dust and the brown sky, which is the dust floating in the air, do you think people would learn to love that? People who came from the Earth, their children, their grandchildren, would they start to feel like that's home?
They will be the most remembered, the most talked about pioneers that have ever set foot on Earth. because they pioneered something that nobody ever did, and they carried it out. The leader who makes a commitment for human beings on the planet Earth. How long we've been here, we came down from the trees, whatever, and we've done kind of piddling things, but all of a sudden...
A couple of cool things, I think.
Yeah.
Earth's 5,000 years old, but
Now,
anyway.
thousands of years in the future, the person on Earth that kind of pushed human beings to go and establish a settlement that began to grow and grow. You don't think that's a small thing in the history of mankind?
Oh, I do, but I think I'm asking for the people who are actually living on Mars.
Yeah?
Will they feel that they are happy,
There'll be
happy in their lives?
more movies written about them, more books and everything.
I think it's like
Laika
the dog. Laika died, but it was a mutt, stray dog running through the streets of Moscow, and now it's more famous than like Lassie.
Yeah.
Right? So if I were a mutt dog, I would want to die in space because people would like talk about me.
They'll be the velvet underground of space exploration.
If only that dog could understand the concept of fame and not just the concept of, oh my God, what's happening to me?
Bringing space and science down to Earth. You're listening to Startalk.
So I'm actually on record for my skepticism regarding the first settlers on Mars. Because when we think of the Pilgrims as an analog, the difference between the Pilgrims landing in the New World and the first team of humans landing on Mars is that in the New World, when they got off the ship, they could breathe the air. Trees were made of wood like the trees back at home. They could rebuild damage to their ships. Food was growing on the branches. I thought of the first colony of Mars as being way more hazardous than what the colonists experienced crossing the ocean. But then I saw the movie The Martian, and I realized that that's the wrong analogy. I wasn't thinking about it the right way. Because the difference is that today we have the advances in engineering, science, and technology that empowers us to take on frontiers that without it would kill us in an instant. And this is a cosmic perspective. You've been watching Startalk, and I've been your host, Neil deGrasse Tyson. And as always, I bid you to keep looking up.
Dropping science like Galileo dropped the orange.
You, powered by data, knowledge, insight. That's you to the power of IBM. Enhance the way you do business at ibm.com/YOU. It's holiday time, and one thing you can count on is plenty of discussions with your friends and family about critically important issues like climate change or what's the greatest catch in NFL history, huh? Okay, I hear you laughing. So your friends and family must be like my friends and family. Well, never fear, because Startalk's got you covered. In this week's Climate Change Mashup episode of Startalk All-Stars, we're serving up all the scientific evidence you can possibly use to convince the climate deniers in your life that things are getting real and that it's time to do something about it. And for those heated debates about football, this week on Playing with Science, we're revisiting one of the most amazing catches in NFL history, Odell Beckham Jr.'s impossible one-handed grab, and exploring the physics that went into the catch and the Nike glove technology that helped make it possible. You can hear either one of those shows right now wherever you listen to podcasts. And remember that you can also watch or listen to these episodes commercial-free, as well as enjoy exclusive original content like Neil deGrasse Tyson's unedited complete interviews with celebrity guests or A Space Odyssey with Neil and Adam